working with quadratic functions today, and one of the most common problems that run into engineering or physics is, when it comes to quadratic functions, is the idea of a vertical projectile. And so the idea is we have some sort of projectile, it's shot, thrown, kicked, whatever, up into the air, goes up for a certain amount of time, and then eventually gravity brings it back down. And the key thing to think of that is when we start graphing it, we'll see a graph that looks something like a parabola, because we're expecting it to be a quadratic. The graph is going to look something like that, but remember, this is time versus height. It's going to look something like that. Remember, the projectile itself is actually just going straight up and coming back down. We could get 2 dimensions involved in that, but that becomes a double problem, where you have one equation that describes the height and another equation that describes kind of length versus time. So this is not height versus distance, this is height versus time. So make sure you keep that idea straight in your head. And so the general equation for these things is that h of t is that it's negative g over 2 times t plus v0 times t plus h0, where the factor in front of the t squared is acceleration due to gravity, so it's generally negative. I put it in there, and actually gravity is usually either 9.81 meters per second squared, or we use that as 32.02 feet per second squared. It's generally the unit you'll see it in. Of course, you may see it in other units as you go through. Someone might want to do it in miles, so that things might do it in miles per hour squared or something like that. It is always going to be some sort of length per time squared to make it the units work out with our dimensional analysis. You also have the initial velocity. Remember, this is the initial velocity with which it's shot upward, the direction we're talking about in terms of height. And then you might have an initial height. So for many problems, either if we talk about a falling ball object, if we just have something that starts here and it only goes down until it hits the ground, we'll have an initial height but no initial velocity. For many problems, like for instance the rocket I drew here, if you can tell that's a rocket, you would have an initial velocity when it takes off, but the height, we're starting it from the ground to 0. And for some cases you might have both parts involved. You might have an object that is, we're starting from a building, we're throwing our ball upwards, and then it comes back down. Whatever the case is, you might have all these 3 factors, you might have be able to remove some of them to simplify it. So let's see the specific example we're talking about here for this problem. Okay, so for this particular problem, we're given that the projectile is fired from the ground in a vertical direction. So looking above, we already know things like if it's fired from the ground, h of 0 equals 0 is what we expect. In a vertical direction, that tells us that v0 is positive, and that we're always subject to gravity. And then they give us this equation which says 96t minus 16t squared gives us our function where h of t is our height in feet and t is our time in seconds. And so that makes sense with what we talked about before. Feet. So this is half of gravity. Gravity is 32 feet per second squared. We've used negative 16 feet per second squared for the constant there. Our initial velocity must be 96 meters per second, or feet per second, sorry. And then they ask us to find several things: the independent and dependent variables. What's the height of the object 1.25 seconds after we fire it? When does it reach a height of 80 feet, or when is it at a height of 80 feet? How long does the projectile stay in the air? When is it at a height of 160 feet? And when does the projectile reach its maximum height, and what is that maximum height? So let's start working through those problems. Part A, an easy question: which is the independent variable and which is the dependent variable? So remember, the dependent is the one that depends on the other factor. So again, we have h of t equals something with t's in it. So that must be t, or time, is the independent, and it's measured in seconds. So, and the dependent is h, which is the height, and that's measured in feet. So that part's pretty easy. This part B just asks when t is 1.250 seconds, what's the height? So we just have to plug that into our equation. So we need h of t is h of 1.25. So it's 96 times 1.250 minus 16 times 1.250 squared. We'll plug that in our calculator. And since this is mixed operations, we'll use 3 significant figures and get that it's 95.0 feet. Again, if you wanted to say that based on our other parts of the problem, we're able to get things out to thousandths, that you might want to round it, keep that all the way out to thousands and make it 95.00 feet, we could have that argument. Continuing on with our quadratic functions, the projectile example, part C asks us when is the projectile at 80 feet in the air. And so we just need to know when h equals 50 to 80. So we'll set our equation equal to 80. So that is 96.00 t minus 16 t squared. And so to set that equal to 0, to solve that, I want to actually have an equation set to equal to 0. So the way I would do that is to subtract 80 from each side. So 0 is going to equal negative 80 plus 96t minus 16t squared. And if you remember from our previous videos, one of the things we want to do is try to take out any common factors we can to make this easier for us to solve. And we could also use several different ways of doing that. So let's look at all different ways of solving that. The first method, because I like it best, is factoring. So let's try using factoring. So I've got factoring, and I've also rearranged it, you'll notice, because I like to have it in the form a x squared plus bx plus c equals 0. So I've put the squared term first, the negative 16, the 96. And remember, our first step in factoring is to take out any common factors. And so if I think about these, obviously all of them are divisible by 2. They're also divisible by 4. They're also divisible by 8. Turns out they're actually all divisible by 16. So I actually factored out 16, and I'm going to go ahead and factor out a negative 16, because as we talked about in previous videos, I don't like dealing with negative coefficients up front. And by dividing out by negative 16, I get a much simpler equation to work with. I get t squared minus 6t plus 5 equals 0. That I can easily factor. I can factor it into t minus 1 and t minus 5. And you can double check and multiply those back together to make sure they work. And then remember, I just set each factor equal to 0, so I get that t equals 1 or t equals 5. And I've used the correct number of significant figures and included units in there. So that's how I would solve it by factoring. Another method I could have used to solve this is using the quadratic formula. In case we don't remember that tells us that x equals negative b plus or minus the square root of b squared minus 4 times ac, and that entire quantity all over 2a. So let's plug in what our values are. So using our equation here, again, we're using t instead of x. Our b value, which is the one that's multiplied by 1, is 96, so we have negative 96, plus or minus the square root of 96 squared minus 4 times a, our factor that's multiplied by t squared, is negative 16, times c, negative 80, and the entire thing is divided by 2 times negative 16. One thing to keep in mind with this is, since I'm going to plug this in my calculator anyway, it doesn't bother me a lot to have large numbers like 96 squared and whatever this multiplies out to be. But remember, I could still divide out first and make it a little bit easier myself. Then I would be dealing with numbers like a is 1, b is negative 6, and c is positive 5. I could probably do that one without having to punch everything in my calculator. But with these large numbers, obviously I don't want to try that. But let's put it in our calculator, and remember, we're going to get 2 different solutions out of there, one for the positive square root and one for the negative square root. Okay, so using that in our calculator, again, I did show a little bit of intermediate just for any of you that maybe aren't using a graphing calculator where you can put it all into one big pot. This part here inside the square root, we got a number of 4096. One thing we need to know about that is if it's negative, that means we're not going to find an answer. The other thing is that since it's a square root, we know our answers are going to come out much more even than they would otherwise. Because apparently this is 24 squared, I believe. No, that's not right. It would be 64 squared. So we can check that there. Again, graphing calculators where you can write the entire equation out are very helpful in this, especially because we can write it once, just go in and repeat the equation and change the sign. If you're using just the scientific that's not good at storing data, you want to be very careful about making sure you're doing things in the right order. You probably want to write out more intermediate steps. And if you're doing it with a big graphing calculator, you want to be very careful about where you place your parentheses and that sort of thing. So either way, it takes a little work to make sure you're getting things right. The other thing we didn't pause to think about is, does it make sense that we get two answers? Well, yeah, it does, because if we go back and think about what's going on here, at this height of 80, it probably passed it once on the way up and once on the way back down, unless 80 happened to be our max. So yeah, that makes sense that you would have two answers. All right, so moving on to part D. So part D asked, how long did the projectile stay in the air? And so really what we're asking is, well, when does it hit the ground? So we're going to set h of t equal to 0 and solve for that. So 96t minus 16t squared has to equal 0. It's technically a quadratic, so I could go through things that I would use to solve quadratic. But really the easiest thing to do is to just pull out the common factors. And I already know from previous that 16 will go into both of these. So 16t is in both of these. So if I divide this by 16t, I'm left with 6. I divide this by 16t, I get minus t. So those are my two possible answers, my two factors there. And my answers would be that t equals 0 or t equals 6. And so those are the two times where h of t equals 0. At time 0, that's at the start. And time 6, that must be at the crash. So mathematically, I have two answers here, but remember the question I'm trying to answer is how long is the projectile in the air? So how long the projectile is in the air, or time of flight, if you want to call it that, is 6.00 seconds. And again, make sure to include units and use the right number of speed figures. So again, just kind of, put the notes on that. We knew it started at h equals 0, so how long it flies is actually just the 6 seconds. So we want to be careful about what we're answering. Part E asks, when does it reach 160 feet? So same sort of thing. Let's set our function equal to 160 and solve that. So we set that equal to 96t minus 16, which is our function. Again, to be able to solve it, I need to set the equation equal to 0. So I'll do that. And then, again, to make things simpler myself, since it turns out this time around that, everything is divisible by 16, I'm going to go ahead and do that first. So I get that t squared minus 6t plus 10 has to equal 0. And so I want to try to solve that. And again, my favorite method is by factoring. If I'm going to factor it, I know it has to be, since I've got a coefficient of 1 now, it's t and t. Since this is positive and the middle is negative, and those are going to be minus both factors. And so I need factors of 10 that add together to get 6. There's really not any. So it turns out I can't do this. So the closest I could get is if I use 2 and 5, but that would give me 7 in the middle, so it doesn't work. So factoring does not work. So factoring does not work from this problem. We were warned that it doesn't always work. So we move on to our other method, which is quadratic formula. So using quadratic formula, I'm going to go ahead and use simplified form. I could go all the way back to this form, but might as well, since I know it reduces to this, and that will give me the same answers. Using the simplified form, b is 6, so negative 6 is going to be positive 6, plus or minus the square root of negative 6 squared minus 4. Remember, a is 1, and c is 10. All over 2. I'll put times 1 just as a reminder. So t equals 6 plus or minus. And again, I'm going to go ahead and simplify what's inside the square root bracket just to help us out. And as I do that, I get a negative 4 in here. So what does a negative 4 tell me? Well, it tells me this can't happen. That for this case, we have no real solution. And mathematically, that might be the final statement that I need to make. But again, we're talking about engineering problems. So what does that mean in terms of engineering? What was the question? When do we reach 160 feet? If there's no real solution, What that means in the real world is the projectile does not reach 160 feet. We need to make that explanation of what's going on here. So it doesn't reach that, is what part E tells us. So the natural next question, part F, is going to be, well, how high does it go? So part F is, what is the maximum height? I'm going to give that a name called H max. And when does it reach that maximum height? I'm going to give that a name called T max, the time when it reaches that. So I'm given this function. How can I figure out what the maximum value is? One way, of course, would be to graph it and trace the line. Not really what we want to do. Because we're going to get to much more complex things, and we want to be able to get these things really accurately. So we want a mathematical way to kind of get there. And so what we're really trying to do is find the vertex, which is, if we draw a quick sketch, we're trying to find the vertex, which is that top point. And so you'll have a lot of questions that ask you to find the max, or if it's a parabola that goes the other way, find the minimum value of when that happens. That's a very important part in our parabola. So how do we do that? So one of the best ways to do that is the tedious method I talked about in previous videos, which is called complete the square. And that's one of the reasons we learn this, is because it's a very good way to find the vertex. So the first step of that is to separate the C factor out by itself and to group the other part. In our case, we're shooting from the ground. Our C value is 0, but I'm just going to put that over there just as a reminder of what we do. And so when you have ones that when C is not equal to 0, you'll understand where that's coming from. The next step is to take that part that's in parentheses, which has the A term and the B term, and factor out A. Maybe I should put that in quotes. We want to factor out A from that part that's in parentheses. So I've taken out A was negative 16, so I divide it out by negative 16, I get T squared, and when I do that part, I get negative 6. And just as a warning, you won't always get an integer here. Sometimes you may sometimes get a fraction. That's okay. That just has to happen. I'm also going to leave my plus 0 on there, again, just to kind of keep up with it. Obviously, you would not need to keep plus 0 anywhere. Okay, so this is the part where it starts getting confusing for most students. Is now that I've got this split apart, what I want to do is take that coefficient that's multiplied just by t, because I know I've got, so it's really the only coefficient that's inside the parentheses at this point. I'm going to divide it by 2 to get that number. And then as I move on, I'm going to take that amount, I'm going to take that coefficient divided by 2. So for our particular example, it was negative 6, I divided by 2, I get negative 3. I'm going to take that value of the coefficient divided by 2 and square it. And I'm going to add that amount inside there. So for us, that is negative 3 squared, which is 9. So I'm going to add 9 in here. Now, because I can't just manipulate, I can't just start adding things to the equation without some sort of balance. Whatever I add in there, I have to subtract outside the parentheses. So the amount, I subtract an amount outside the parentheses equal to A times that coefficient, because A is multiplied by everything inside that coefficient. So I need to multiply that here by negative 16 times 9. And again, this comes from just these two things. It comes from here, and it comes from here. And notice it is a subtraction sign there. Addition inside, subtraction outside. That's how we keep the world balanced. The next step would be to simplify the part that's in parentheses to being t minus the coefficient we found up here, that quantity squared. And then, of course, we can also simplify the stuff that's going on there. So what does that look like for our problem? So for our particular problem, remember our coefficient was negative 3, so I have t plus a negative 3, or t minus 3 in parentheses squared. And then I just, negative 16 times 9 is negative 144, so minus a negative 144 is the same as plus 144. Or 0 minus a negative 144 is plus 144, however you want to look at that. So now I've got this expression for my equation, and you can check this, that if I multiplied all this out and did everything, I would come back to this expression. That these are the exact two, these expressions are exactly equal, just written in a different form. But the nice form about this is what we call this form is vertex form. And so it is, in generic terms, it's y equals a times x minus h squared plus k, that the vertex is the ordered pair h, k, where h is the horizontal one, or the x component, and k is the vertical, or the y component at our vertex. And one of the ways we can tell that is because we know if x is equal to h, that part goes to 0. So the only part we have is this vertical y component. So for our particular problem, that tells us the vertex. The vertex is at 3, 144, or to put it in ways that the question actually asked. So the label in terms of the variables I made up at the beginning of this part. The maximum height is 144 feet. The time it takes to get to that height is 3 seconds, or to write it in words, which is what we want. The projectile reaches a maximum height of 144 feet, 3.00 seconds after it is launched. So if we draw a quick sketch of this, we can learn a lot about it. One of the things we can learn about it is that for the case where the projectile is shot from the ground, that the maximum height is reached halfway through that time. So if it's shot from the ground and it returns to the ground, since it took 6 seconds for the entire time of flight, the vertex is here in the middle at 3 seconds. And we got it was a height of 144 feet. We can also mark, we know our other point, we know because of previous parts that at 1 and 5 seconds, it was at 80 feet. We know it never reaches 160 feet. So again, that could be our sketch there. So just to kind of help you out with that.